Rutherford's gold foil experiment. In the 1900s, the leading theory of atomic structure was the plum pudding model. But that was all about to change. Between 1906 and 1913, Hans Geiger and Ernst Marsden conducted a series of experiments under the direction of Ernest Rutherford, who often takes much of the credit. These experiments eventually led to the Rutherford model of the atom. But what are the key takeaways? And what followed on from this? In the experiment as retold for GCSE, the scientists involved fired alpha particles, positively charged helium, nuclei, at a relatively thin sheet of gold foil only about 1,000 atoms thick. They also used a fluorescent screen to detect the deflected particles. Most of the alpha particles passed straight through the foil. This tells us that the atom is mostly empty space. A small number of the particles were deflected at angles. This suggests that there is an area of positive charge in the atom, as positive repels positive. A few bounced back at very large angles. This final observation is evidence for the fact that this area of positive charge was very small and concentrated, as the course an alpha particle would need to take to bounce straight back would have had to be incredibly precise and thus unlikely. So, Rutherford's gold foil experiment gave us the idea of a nucleus, the idea that an atom is mostly empty space, and also led to the nuclear model of the atom. Ironically, Rutherford himself was surprised by these results to such an extent that, he said, it was almost as incredible as if you fired a 15-inch shell at a piece of tissue paper and it bounced back.